Assalamualaikum and salam sejahtera. So next we will continue the carbohydrate topics on the strength of starch. Okay, please remember starch is a type of polysaccharides. Okay, when you add starch with water, okay, more starch, stronger the gel. Okay, whereby you add more starch to the water. Okay, the gel that you can get is stronger. Okay, for the proportion of amylose, okay, it is normally act or aid or assist the gelling process. Okay, it will make your product or ingredients become jelly-like. Okay, in terms of the presence of sugar, okay, in the starch, for example, you put sugar, starch, and also water. Okay, so the sugar will compete with the starch to get more water. Okay, but it is also reduce the strength of the starch. Means the sugar will reduce the strength of the starch. Okay, if let's say the starch you combine with acid, okay, the hydrolysis of the starch will be produced. Okay, and then it is also reduce the gel strength. Okay, it means that both of the ingredients of sugar and acid will reduce the gel strength. Okay, next we look at the effect of ingredients on the starch. As I mentioned earlier, okay, when you combine sugar and also starch with water, okay, the sugar itself will compete with the starch to get more water. Okay, so it is called as hygroscopic. Okay, hygroscopic. Compete with starch to get more water. Okay, and then if let's say the starch you combine with sugar, of course with the water, okay, it will gelatinize. Okay, and if you put some heat or you heat the ingredients of starch and sugar with water, okay, so gelatinization will be delayed. Okay, means that if let's say you just add starch and water, maybe you put some heat, okay, so the gelatinization maybe will occur around 5 minutes. And then if let's say you put sugar, starch and also water and you heat it, okay, you put some heat, and then the gelatinization will took longer period, maybe 10 minutes, okay, to boil or to become gelatinized. Okay, the sugar itself, okay, increase the translucence of the starch. Okay, it will reduce the paste viscosity. Okay, if let's say you boil the starch, sugar and water, okay, the viscosity of the ingredients reduce. Okay, and then it will lesser the gel strength. Okay, next, effect of the acid to the starch. Okay, for example, you use a starch acid and you put some heat. Okay, normally the hydrolytic reaction will occur. Okay, the pH 4 and below, you will get, okay, and then the granule starch become smaller. Okay, and then in terms of consistency or viscosity, yeah, it will thin or less, yeah. And then how to control this process? Of course, you need to control the pH. You need to control the rate of heating. Okay, and then you need to know the time to add the acid in the ingredients. Okay, next, when the starch combined with fats and oil, okay, it will influence the gel strength. For example, guys, when you use egg yolk, you combine with the starch, okay, it will thicken the starch. Okay, in terms of the temperature, For example, egg yolk, okay, it will affect the coagulation temperature, and then it will become a fluid gel. Okay, what is the meaning of coagulation? Coagulation occur, for example, when you cook what we call some dishes, for example, masak lemak, right? Okay, and then you put some heat. Okay, coconut milk, you boil it. Okay, or maybe you put egg inside the soup, and then you boil it, and then there's a egg that already broken down, right? And then there's a whitish color, what we call ingredients of the egg to the liquid. Okay, so that's a coagulation process. Okay, then next, okay, the functions of carbohydrate in human body. Okay, normally, of course, become the energy source. Okay, for your muscle contraction when you move your body. Okay, so because of the energy that you get from the carbohydrate. Okay, and then of course your brain need to have the energy. So the energy comes from the carbohydrates. And then it is also a protein sparing. What is the meaning of protein sparing? Okay, when glucose or glycogen low in your body and no free fatty acid available. Okay, so the protein in your body will convert to glucose, as I already explained to you guys in the class. But you need to be more careful for the protein sparing. Okay, it is actually bad for a few reasons. Okay, whereby when the protein converted to the glucose, okay, first tissue mass decrease. Of course, for those of you who want to reduce your tissue body mass, okay, or you want to reduce your weight, you want to what we call you want to practice this, but it is advised not to do over practice, yeah. And then this one, the kidneys will overwork. Okay, your kidneys will overwork when the protein need to convert to glycogen first, and then glycogen and need to convert to what we call glucose, so your kidney will overwork. So be careful on that. Yeah. Okay, then uh, what we call they fill numerous carbohydrate fill numerous roles in living things. Okay, for example, storage and transport of energy. Okay, structure components for the plants. Okay, in terms of the cellulose and chitin in the animals. Okay, carbohydrates also play major roles in our immune system. Okay, fertilization, pathogenesis, blood clotting, and of course development of human body and also human growth. Okay, important to help the body use fat efficiently. Okay, to prevent ketosis, I want all of you to find what is the meaning of ketosis. Okay, to prevent constipation and also act as a lubricant for the fiber part. Okay, this one functions in food preparation. I already mentioned to you guys. Okay, next we look at the carbohydrate as a natural sweetener. Okay, the sweeteners from the carbohydrates come from, for example, sugarcane, sugar beets, maple trees, and also corn. Yeah, and then these sweeteners is actually categorized, yeah, into three major groups. Okay, how they categorize is it is actually based on their different chemical structures. These different chemical structures will influence the function of the natural sweetener in food and beverage industry. Okay, for example, we have three groups. First one, sugars. Okay, we call as sugars. Second, syrup, and third, sugar alcohol. Okay, for the syrup, okay, it is varies in terms of viscosity. okay, and also concentration, flavor, and price. Not only that, okay, you can have it in the kitchen, for example, or maybe at your house, okay. Corn syrup, okay, high fructose corn syrup, honey, molasses, maple syrup, and also invert sugar. Okay, so next we look at the corn syrup. Okay, corn syrup is actually a byproduct from the cornstarch production. It is a liquid form. Okay, it contains 75% of sugar and also 25% of water. Okay, and then normally manufacturer use the corn syrup in soft drink and also processed food. Why they use the corn syrup? In order to reduce the manufacturing costs. Okay, and then how corn syrup is made? Okay, they add a weak acid solution to the cornstarch. Okay, and then they boil, they filter, and then evaporate the mixture or the ingredients, okay, until the concentration that they want to achieve. Okay, and then they also add the enzyme to the cornstarch, whereby the enzyme will convert the starch into dextrin. Okay, dextrin it might be in a glucose form, maltose form, or small polysaccharides form. Okay, next, okay, beta amylase enzymes, okay, will yield or produce more maltose. Okay, glucoamylase enzymes will give a higher glucose syrup or produce higher glucose syrup. Okay, high fructose corn syrup, okay, normally made by converting glucose isomerase enzyme, and then it will be converting to a syrup with the proportion of 40% fructose and also 50% glucose. Okay, for the molasses, hopefully you can Google the pictures, yeah, guys. It is actually thick, yellow to dark brown liquid byproduct from the sugar cane or beets, okay, from the sugar cane or beets, okay, and then the liquid, okay, repeatedly boil, okay, and then after that the end product, okay, from the boiled liquid called as molasses. Okay, the proportion or the what we call combination of the ingredients, okay, 75% water, 5% ash, okay, and then the other are the liquid, the concentrated liquid that have been boiled. Okay, and then most commercial grades of molasses are actually blends of different types of molasses. I don't want to explain details on the grades of molasses, but at least you know what is the molasses. Okay, invert sugar. Okay, normally invert sugar available in clear, okay, liquid form, and it is a sweeter, okay, rather than granulated sugar. Okay, and then this invert sugar commercially made, okay, by dissolving the sucrose in water. Then they heat the solution, they add the cream of tartar, okay, or they put an enzyme. Okay, this enzyme called as invertase enzyme, okay, specifically known as sucrase. Okay, whereby this enzyme will hydrolyze the sucrase into the two portion. Okay, first portion called as glucose and second portion called as fructose. So this process is actually called as inversion. Okay, so next we look at the sugar alcohol. For the sugar alcohol, they're naturally found in the fruits and vegetables, okay, from the hydrogenating process. Okay, and then few names of the sugar alcohol such as sorbitol, mannitol, xylitol, maltitol, isomal, lactitol, and erythritol. Okay, so the sugar alcohol is actually have few properties or characteristics. Okay, it has the ability to contribute the sweetness to the food. Okay, combined with the tendency to be slowly absorbed. Okay, and then very useful ingredients in dietetic food. Yeah, and then for the sorbitol, mannitol, and xylitol, okay, you can see the calories here, 1.6 to 3.0 calories per gram compared to the sucrose, okay, 4 gram. Okay, and then sugar alcohol also is cavity preventing because they cannot be digested by the bacteria, okay, which is responsible for dental caries in human. Yeah. Okay, but there are a few problems with the sugar alcohol. Okay, whereby sugar alcohol are more slowly absorbed from the small intestine than other sugar. So people who always use or consume sugar alcohol can have the diarrhea, abdominal pain, and gases or bloated in their stomach. Okay, and then consumption of food products, okay, containing over 30 gram of sorbitol is not recommended, and only limited quantities of xylitol are allowed. These are based on the what we call rules and regulation, food rules and regulation. Okay, so the alternative sweetener, we can refer to the acceptable daily intake. Okay, ADI for aspartame and asulfame. Okay. The values for saccharin and sucralose are referred from United Nations Joint FAO or WHO Expert Committee on Food Additive. You can refer to, yeah. Okay, so next we continue our topic on the enzymatic browning or browning. Yeah, so browning is actually the process whereby your food become a brown in color. Okay, change the color from the natural color to the brown color. And then there are two types of browning process. The first one we call as enzymatic browning process. The second one we call as non-enzymatic browning process. Okay, please refer to the word enzymatic, non-enzymatic. Means the browning process use enzyme, and the other one, the browning process didn't use any enzyme. Okay, so first we look at the enzymatic browning. Okay, enzymatic browning, it is actually a process or the changes of color reaction that occur, okay, for the three items: fruits, vegetable, and seafood. Please remember these three items: fruits, vegetable, and seafoods. Okay, it is actually um, what we call chemical process, okay, which involve an enzyme, okay, called polyphenol oxidase. There are also a few enzymes, but here I want to stress more on polyphenol oxidase, whereby this enzyme polyphenol oxidase will create melanin. Melanin is actually a surface, okay, to the fruits, vegetables, and seafood, okay, that resulting a brown color to this type of food. Okay, so how it occur? Okay, the reaction occur normally during food preparation and also storage. Okay, for example, you cut the potato, okay, cut an apple, and then you put on a table, okay, on air or room temperature, then your apple will become brown color, right? Okay, so it is actually enzymatic browning process. Okay, and then some of the browning process desirable by people, but some are not. undesirable, means undesirable. Okay, so that it is important to control, okay, to inhibit or encourage as needed. Okay, and then some are catalyzed by enzyme. Okay, and then for no enzymatic reaction, okay, some involve carbohydrate. Okay, these are the prevention of browning reaction for the what we call fruits, vegetables, and seafood. Okay, the first one, you need to decrease pH to below 6.0. You need to check the pH. Second, you decrease the temperature. Okay. Third, lower water activity. Okay. Then next, remove reducing sugar. Okay, next, remove cuprum and ferrum. Lastly, okay, you need to use chemical inhibition. Okay, for example, you use sulfites and bisulfites. Okay, these are the economic benefits of browning in fruits and vegetables. Of course, it will give overall acceptability of the foods to the consumers. Okay, and then for example, tea, black and green tea. Okay, when you use the enzymatic browning process, it will assist the color and flavor development. Okay, for the cocoa, okay, it will give a color development. Okay, and then okay, the color development occur during fermentation and drying process of the cocoa production. Okay, the enzyme polyphenol oxidase responsible for the characteristic golden brown color in dried fruits, for example, raisin, prunes, dates, figs. Okay, and then these are the economic losses. Just now we look at the benefits, but now the economic losses due to browning process in fruits and vegetables. The first one, unacceptable color. Okay, and the other one, deterioration of quality. So it will what we call affect the acceptance of the fruits and vegetable among the consumers. Okay, and even enter the international market. For example, you have 40 box of the fruits. Okay, and then 10 box or 30 box deteriorate in terms of quality due to the browning process. So only what we call only 10 box. Okay, so you have problem there. Okay, and then it will didn't meet the requirement by the what we call supermarkets or international markets. Okay, and then the solution to control the economic losses, okay, or to reduce the losses, we need to control the process of enzymatic browning. Okay, so how to control the browning process, okay, in the fruits, vegetable, and also seafood. Okay, the first one, we use a technique of elimination of oxygen. Okay, how you want to eliminate the oxygen? Okay, when you cut the fruits, the vegetable, make sure, okay, you eliminate the oxygen from the process. Okay, and then for example, you cut the apple and then you put in the water or salted water, right? And also sometimes you cut the fruits and then you put in the freezer, in the chiller. Okay, browning, however, occurs rapidly upon exposure to oxygen. So when you exclude the oxygen, okay, by immersion in water, as I mentioned just now, you put in the syrup, brine, or you can also use the vacuum treatment. Okay, the other one, inactivation of the enzyme. Okay, inactivation of the polyphenol oxidase. Okay, using the heat treatments. Okay, for example, steam blanching. Steam blanch the vegetables and the broccoli, yeah, For example, okay, you can control what we call the browning in the fruits and also vegetables. Okay, and they also steam blanch the fruits and vegetable that they are going to can or frozen the product. Okay, chemical modification of these substrates can, however, prevent the oxidation. You can also use the chemical modification. Okay, next, okay, you can use the killer enzyme. Okay, you can use ionizing radiation or refrigeration. Okay, so that's how you control the browning process. Okay, in fruits, vegetable, and also seafood. Okay, next on non-enzymatic browning. Okay, this process is actually, as I mentioned earlier, similar. Okay, the change color of the foods to the brown color without the activity of enzymes. The melanins or the surface of the foods, okay, and other chemicals are responsible the brown color. Okay, and then the two process or the two forms of non-enzymatic browning come from caramelization and Maillard reaction. Okay, first caramelization is actually a process of oxidation of sugar. Sorry. Okay, oxidation of sugar. And then normally we always use this process. Okay, and then this process resulting nutty flavor and also brown color. Okay, as the process occur, volatile chemicals are released. Okay, and then we produce a caramel flavor. Okay, for the Maillard reaction, it is a chemical reaction between amino acids and reducing sugar. Okay, with the addition of heat. Okay, and then how it occur? The sugar will interact with amino acid. Amino acid is actually a protein. Okay, and then it will produce odor and flavor. Okay, so I give you example for caramelization. When you want to prepare cream caramel, you caramelize the sugar. You put sugar on a small pan, and then after that you put on stove, the pan on stove, and then you put some heat. Okay, then the sugar will be caramelized. Okay, it will change in terms of color from white to brown color. Okay, and then you can smell the odor of caramelization, caramel flavor on that. Okay, that's the easiest example. Yeah, and then the other one, okay, Maillard reaction. Maillard reaction occur, for example, protein that you use. Okay, um, for example, cake or any soft roll or bun. Yeah, we use soft roll as example. Soft roll that you prepare from the starch, okay, or flour is actually contain protein. Okay, so when you have the dough of the soft, this what we call the dough of the soft roll. Okay, and then you have the small soft roll. Okay, before you heat it, okay, you put in the oven, right? You put in the oven. Okay, then the soft roll in the oven. Okay, when you put when you on the oven, when you what we call when you put some heat, when you have the when the soft roll are bake. Okay, so the oven has the heat. The oven will be circulated in the heat will be circulated in the oven, and then the soft roll become brown. Okay, so because of the protein content in the soft roll, okay, the protein content comes from the starch in the soft roll are heated by the heat circulation from the oven. And then the color of the soft roll from the light yellow become the brown color. So that's the Maillard reaction. The other examples of Maillard reaction is the meat. When you grill, okay, you grill meat, you can see, okay, the surface of the meat from the red color become brown color. That's example of the Maillard reaction. Okay, so the results of non-enzymatic browning normally loss of amino acids or protein. Okay, amino acids here normally lysine, arginine, and histidine. Okay, means that when you put some heat, then the protein will lose. The formation of mutagenic products. Okay, that's non-enzymatic browning results. Okay, this what I have mentioned to you about Maillard reaction. But here it is important to highlight to you that when the Maillard reaction occur, okay, there's a removal of water molecule, but we can't see from our what we call eyes directly in the oven, right? But in terms of chemistry, chemical reaction, there's a molecule of water produced. Okay, and then a series of chemical reaction occur during the Maillard reaction. Include the fragmentation and polymerization with the eventual formation of brown pigments. Okay, so these are the caramelization. Okay, where as I mentioned to you earlier. Okay, next we look at the chemical reaction on carbohydrates. There are few reaction occur for the carbohydrate. Okay, from the starch form. Okay, there's a hydrolysis process. Okay, the first one, hydrolysis process, whereby the starch, okay, will be converted to the dextrin. Okay, then the dextrin will be converted to maltose, and then after that you can get the glucose. How it occur? Okay, hydrolysis, okay, occur by enzymic action. Okay, and then it is important for the bread making and brewing. Okay, whereby it will produce maltose, a kind of sugar, a simple sugar. Okay, whereby the yeast enzymes will be able to break down. This is, sorry for the typo error. Break down the what we call starch into the carbon dioxide and also alcohol. So in the hydrolysis process, okay, of course at the end the maltose will be produced, but at the same time carbon dioxide and alcohol also be produced. Okay, next on dehydration. The process of dehydration, okay, also consists the removal of moisture from the food. You remove the moisture content of the food, okay, through the dehydration process, and normally we use heat for this process. Okay, and then the temperature should not be too high. Okay, and then the excessive heat may cause case hardening. Okay, case hardening, if let's say you dehydrate some food, okay, case hardening occur whereby you can see the food, okay, the outside of the food becomes brittle and also hard. Okay, because of the moisture is trapped in the center. Okay, so that's the dehydration. Okay, for the, and this is the hydrolysis, as I mentioned earlier. Okay, these are the types of dehydrating foods. Okay, so first one, they use a tunnel drying. Hopefully you can watch the video on the tunnel drying, how they use the tunnel drying to dehydrate foods. Okay, for the tunnel drying, they use a conveyor belts or tray. Okay, and then they also use the warm air tunnel Yeah, they put the food on the conveyor belts or tray, and then it will move around. Okay, it will move around, and then there's a warm air. Okay, warm air is blown upwards, and the particle of food are kept in motion in the tunnel. Yeah, and then this tunnel drying normally used for vegetables. Okay, spray drying. Spray drying normally drying liquid food. Yeah, for example, milk. You can have a powder when you use the spray drying. Okay, so same here. They also use a warm air during the spray drying process. Okay. Okay, next, roller drying. Roller drying, okay, whereby applied in paste form as a thin film to the surface of a revolving heated roller or drum. The drum rotates, the food dries, and the dried product is removed from the drum by a scraper knife. Okay, means that what? If let's say you want to dehydrate a paste, they use a roller drying roller. Okay, so the paste you put on the roller, then the roller will turn around at the same what we call same drum, same machine, and then after that, okay, there's a heat. Okay, there's a heat, then the food will become dry. Then after that, you need to remove the dried food from the drum, okay, using a scraper knife. Okay, normally they use for breakfast cereals and also potato. Okay, next on the freeze drying. Okay, the food first frozen, and then after that they put some heat, okay, in a vacuum cabinet. Okay, then the product normally porous. Okay, and then can be rapidly rehydrated in cold water. This freeze drying normally, for example, fish, shellfish, meats, fruits and vegetable. You freeze first, and then after that you put in the vacuum cabinet. Okay, using a heating process. Okay, and then that's all. Thank you guys. Hopefully you understand this topic. And then please watch this video. If let's say you have problems, you just ask me. You can prepare questions so that I can answer it. Thank you very much. Good luck. And then hopefully you enjoy this video. Thank you.